Hello everyone. Today's session is about open loop or true synchronous mode or self-controlled mode of control of synchronous motor. We all know that the speed of the synchronous motor is the synchronous speed, and we all know that the synchronous speed is a function of the supply frequency. The speed of the synchronous motor can be controlled by varying the supply frequency. But this method was not used in the previous days because of the unavailability of the economical variable frequency sources. But due to the development of power electronic converters, this method has become more attractive. The speed control of synchronous motors can be done in two modes. The first mode is the open loop or true synchronous or separate control mode. In this mode, the speed is controlled by independently controlling the frequency of the power electronic converter. The second mode is the self-synchronous or self-controlled mode. Here, the motor speed is controlled by varying the converter frequency in line with the rotor position. Now we will see the open loop or synchronous. This method is applicable for multiple permanent magnet or synchronous reluctant motors. This is used in applications such as fiber spinning, textile mills, or paper mills, where close tracking of the speed is required among the multiple machines. The voltage command V star is produced by a function generator where voltage is generated in proportion to the frequency up to the rated frequency, and after the rated frequency the voltage is maintained at the rated voltage of the machine. In this mode, the supply frequency is controlled by an independent oscillator, hence the speed can be controlled in open loop by changing the frequency. An increase in the frequency causes the magnetic field speed to increase and become more than the rotor speed, which leads the torque angle to increase. Therefore, the motor accelerates in order to follow the frequency. A decrease in the frequency makes the speed of the rotating field speed to decrease. Therefore, the torque angle becomes negative, which causes the motor to decelerate to follow this decreased frequency. The change in the frequency must be gradually increased or decreased in order to allow the rotor to track the speed of the revolving field to avoid the pullout of the machine. The motor can be started by increasing the frequency gradually from zero. This method will allow the lower current to flow during the starting. This block diagram shows the open loop or separate control mode of operation of synchronous motor. Here, the voltage source inverter is a 6-step inverter. The required frequency command is obtained from a delay circuit to which the set frequency is given. The same frequency command is given to the function generator, which also does the flux control. The function generator generates the voltage in proportion to the frequency up to the rated frequency. After the rated frequency, the voltage is generated at the constant value, which is maintained at the rated value. The voltage command is given to the firing circuit, which will produce the required firing angle to trigger the switches of the controlled rectifier, which will produce the voltage in accordance with the voltage command given. The required voltage and the required frequency commands are given to the voltage source inverter, which will produce the required voltage and frequency in order to have the V-wave control of the synchronous mesh. The same method can also be used if the same method can also be implemented with the help of the three-phase PWM inverter. If we use three-phase PWM inverter, then in that case, the rectifier can be of diode bridge rectifier. The required voltage and the frequency command can be given directly to the three-phase PWM inverter, which will produce the required voltage and frequency for obtaining the V-wave control of the synchronous machine. Thank you.